Question says, consider the product shown below. Which substrates, our answer choices 1, 2, and 3, would be capable of forming this product using the reagent shown? So we can take a look at this reaction. A couple of things that are important to notice. Number one, what type of reagent do we have? This reagent is a water molecule, and we can classify that as a weak nucleophile / a weak base. So weaker reagents tend to favor unimolecular reactions if we're considering things like substitution and elimination. The type of product that we have is an alkene. So that is telling us what type of mechanism is going to be happening here. In order to make an alkene, we have to have an elimination reaction. So the key mechanism for this reaction is going to be E1. So that will help us a ton in thinking about our answer choices and which one of them is going to be a capable substrate that can produce that tetrasubstituted alkene. So let's look at answer choice number 1. If we're looking here, what I recommend doing, since we know this reaction is a unimolecular reaction, is to draw out the carbocation that's going to form. So in this case, we would make a secondary carbocation. And the choice of answer choice number 2, we will make a tertiary carbocation. And then in the case of answer choice number 3, the chlorine will leave, and we will make a carbocation that looks like this, also tertiary. So whenever you make carbocations, there should be a little red flag that goes off in your mind that says, look for carbocation rearrangements. And that's really important, especially in the case of our first molecule. Here we have a secondary carbocation, but after a methyl shift, we will be able to form a tertiary carbocation. And that's super important because the major products of that reaction will come from the more stable carbocation, the tertiary one. If we look at the carbocations in 2 and 3, they're both tertiary, and resonance isn't a possibility. So the carbocations we formed in 2 and 3 are stable as is, they won't rearrange. But we do see a rearrangement with answer choice 1. Okay, from here, we need to think about, can we form the tetrasubstituted alkene that was shown as the answer for this reaction? And the key to that is thinking about where are the beta carbons and are there beta hydrogens present? So here's our original alpha, and it does have a beta hydrogen there that we can remove to form the desired alkene product, like so. In the case of molecule 2, there is a hydrogen located at this beta position. There are multiple beta carbons, but we need a beta hydrogen in a location that will give us the desired alkene, and it does have one. So we make that alkene as well. And then in answer choice 3, we can see here that there is also a beta hydrogen atom that can be removed to make the tetrasubstituted alkene in the answer to give us the exact same pi bond that we're looking for. So if we think about our options, all 3 answer choices, 1, 2, and 3, so answer choice E, are capable of making the tetrasubstituted alkene as the major product of this reaction.